Welcome to this introduction to 3D printing slicing. In this module, we will explore what a slicer is, how it works, and how to prepare your model correctly before printing. This video is part of the 3D Eco-Fashion project on 3D printing, co-funded by the European Union under the Erasmus Plus program. Let's begin. In 3D printing, a slicer is the software that translates your 3D model into instructions the printer can understand. It takes a digital model, usually in STL format, and divides it into thin horizontal layers. Then it calculates all necessary printing parameters and generates a G-code file. This G-code contains step-by-step commands that guide the printer in building your object layer by layer. There are many slicer programs available, and most of them are free to use. Almost every 3D printer manufacturer provides its own slicer, optimized specifically for their machines. In most cases, it's best to use the slicer recommended by your printer manufacturer, since it includes pre-configured profiles and tested default settings. However, most slicers are built on similar open-source foundations, so they often share similar functionality. For this course, we recommend using Bamboo Studio by Bamboo Lab. There are several ways to import a 3D model into Bamboo Studio. The simplest way is to download a model in STL format and double-click it. If Bamboo Studio is set as your default application, it will open automatically. Alternatively, you can open Bamboo Studio manually, create a new project, and use the Cube Plus button to import your model. Bamboo Studio has two main working modes, Prepare and Preview. In Prepare mode, you see the model exactly as it was imported. This is where you adjust settings and position the object. After clicking Slice Plate, the software processes the model and generates the G-code. It then switches to Preview mode, where you can inspect the generated toolpaths and examine the print layer by layer before starting the print. Some slicer settings are used in almost every print and have a major impact on quality and performance. Layer height defines the thickness of each printed layer. Smaller layer heights produce smoother surfaces but increase print time. Larger layers print faster but reduce detail. Infill density controls how solid the inside of the object is. Higher infill increases strength and weight, while lower infill saves material and reduces print time. Wall/perimeter count determines the thickness of the outer shell. More walls increase strength and durability. Top and bottom layers define how thick the solid top and bottom surfaces are. Print speed affects how fast the printer moves while extruding. Higher speeds reduce print time, but may lower quality. Supports automatically generated structures that hold up overhangs during printing. Required for complex shapes, support type and density can be adjusted to balance support strength and ease of removal. Brim/skirt/raft. Bed adhesion helpers used to improve first layer stability. These settings are adjusted in almost every print and form the foundation of slicing. Before slicing, you can modify your model using the tools in the upper toolbar. You can scale the model to change its size. Rotate it or lay it on a specific side for better stability. You can cut the model into separate parts. Arrange multiple objects automatically on the build plate. Or reduce complexity to simplify high polygon models and improve slicing performance. Proper model preparation ensures better print results. Now you understand how slicing works and how to prepare your model for printing. Once all settings are configured and you have reviewed the preview carefully, you are ready to start the process. Simply click the print button, send the file to your 3D printer, and begin printing. Every successful print starts with proper slicing. Test, adjust, improve, and let your ideas take shape layer by layer. Happy printing!